All right, Luke, we're going to talk about surface area together. You ready to go?
Yeah.
Okay, so I've shown three-dimensional figures here. A rectangular prism, that's kind of like a box. A triangular prism, that's like a shape that has a triangle at one end and then is kind of like a three-dimensional figure going out. And then a square pyramid that has a square on the bottom and then triangles that are on the sides, okay?
Okay.
Okay, so we're going to find the surface area of each. Now, surface area is really useful because let's say you're painting the outside of a building that might be the same shape as this rectangular prism here. You need to know how much paint to buy. So you need to know how much area is on all over that surface, okay? So that might be the front and the sides and the top and the back. All of those areas you might need to be able to know how much paint to buy, right?
Yeah.
Okay, so that's why surface area is useful. And we're going to first start over here with the rectangular prism. And one of the ways that you can visualize how much area there is on the surface is by creating what's called a net, which is basically like unfolding the shapes. Let's go ahead and look at what that would look like with this rectangle. So what I've done is I've just basically pulled that apart like it was a cardboard box almost. And then I've got all of the parts of it. There's the top here, and then that's connected to the back, and that's connected to the bottom, that's connected to the front. And then there's the two sides. You see if I folded this up, I would get this shape over here?
Yeah.
Okay, cool. So now if we're going to find the area, we just have to find the area, the surface area, we just have to find the area of each one of these shapes, right?
Yeah.
Okay, so let's do them one piece at a time. So the area of the top and the bottom is, does it make sense that that would be W times L from what you see here?
Yeah.
Okay, yeah, the top is W times L and the bottom is W times L. And so the area of those two together is WL plus WL. What's a simpler way to write that?
WL times 2.
Yep, or 2WL, right?
Yeah.
Okay, now, what about the area of the front and back? Okay, does this make sense that the front is H times L or LH?
Yeah.
And how about the back?
Yeah.
Yep, okay, so what's a simpler way to write that?
2LH.
Okay, good. Now tell me about, let's see, what didn't we do yet? Oh, we didn't do the sides. So tell me what you would write for the sides.
W times...
You can look at the diagram on the left, or you can look at the net. So here's a side right here, and W is one dimension, and if you folded this up, it would match right along here. So what's the other dimension?
Oh, W times H.
W times H, right? And does that make sense when you look over here too?
Yeah.
Yeah, it does, okay. So the two sides are going to be WH plus WH. Does that make sense?
Yeah.
And a simpler way to write that?
2WH.
2WH, excellent. So now, is that all of the surfaces?
Yeah.
Okay, so how would we write the surface area?
2WL plus 2LH plus 2WH.
Okay, like that?
Yeah.
Okay, great. So that's one way to write the surface area for a rectangular prism. Some people like to simplify this a little bit. Is there anything that's common in each one of those terms that you could kind of pull out?
The 2.
The 2, right? So we could factor the 2 out of there, and then we would have something that looks kind of like this. Does that make sense?
Yeah.
Because if you use the distributive property to multiply that 2 back in, you would have the expression right here, right?
Mm-hmm.
So sometimes it's easier to pull those common factors out, and then you only have to enter stuff in here if you're actually calculating the surface area. Some people prefer this one, some people prefer this one. Okay?
Okay.
All right, so now let's go over to a triangular prism. Now this one again has a triangle on the front, and then it has what shape on the sides?
Rectangle?
Rectangle. So if you were to pull it out, can you start to envision what that net would look like, what the unfolded triangular prism would look like?
Yeah.
How many triangles would it have?
2.
And how many rectangles would it have?
3.
Okay, so would it look something like that?
Yeah.
Okay, very cool. All right, so now let's look at the area first of the two triangles. What's the formula for the area of a triangle? Do you remember?
No.
No? Okay. So what we have here is this triangle has a base and a height. And the area of a triangle is 1/2 base times height. So for this triangle right here, what would that be? What would the formula for that be?
L squared times H.
H, yeah. And actually it's L with a 2, not in the squared, but it's just down here. And that's just to kind of label it so that we don't mix it up with L3 or L1. So it's just L2. So 1/2 L2H would be that triangle, and the other triangle would be the same, right? So, or I'm sorry, it's L1H. So does that make sense there? The front and the back are 1/2 L1H plus 1/2 L1H.
Yeah.
Okay, and is there a way to combine that to make it simpler?
Yeah. 2 1/2 L1H.
Good. And what's 2 times 1/2?
1.
1. So what's the simplest way to write it?
1 L1H.
And it's even simpler than that?
L1H.
L1H. There you go. Good job. Okay. So that's for the front and the back. Now, how about the sides? How about the, well, let's just go ahead and say the bottom. Sorry. Does that look right, that that one is L1 times W?
Yeah.
Because it's a rectangle, right?
Yeah.
Okay. How about the other two sides? What would they be?
L3W
And
L2W.
okay, so the left is L2W and the right is L3W. Does that make sense?
Yeah.
Okay, good. So now if we're going to do the surface area, how would we write that?
L1W plus L2W plus L3W.
And then the front and the back, you would include those?
L plus L1H.
There you go. Something like that?
Yeah.
Okay, good. And now there is like 3 of those terms have something in common. Can you see what you could factor out of 3 of the terms?
L1.
L1 is in 2 of them.
Oh, W?
Yeah, W is in 3 of them. So we could also write it something like that. Keep that first term as L1H, and then plus W times L1 plus L2 plus L3, right?
Yeah.
Okay, so that's, you could use whichever one you prefer, and you actually don't have to memorize these formulas. The key is that you understand how to take a 3-dimensional figure like a triangular prism and then unfold it like this. So let's do one more really quick. It's a square pyramid. So can you describe what this would look like if you were to unfold it, if you were to create a net?
There would be 4 triangles and a square in the middle.
Okay, would it look like that?
Yeah.
Okay, very cool. And with we have the dimensions there. S is the side of the square, and H is the height of the triangle that's kind of slanted there on the side of the pyramid, okay? So what would, let's figure out the area of the square first. What would that be?
S times S.
S times S. Is there a simpler way to write that?
S squared.
S squared. Okay, very good. And then how about the area of one of the triangles?
S times H divided by 2.
Divided by 2. So one side would be 1/2 SH, or SH over 2. Good. Now how many sides are there?
4.
So if we do area of all of the sides, it would be 4 times that, right?
Yeah.
Can you simplify that at all?
2.
Yep.
2SH.
2SH, right? And now can we put this all together?
Yeah, 2SH plus S squared.
Good. Surface area equals S squared plus 2SH, right?
Yeah.
Okay, very good. All right, so what's the key skill here? I think the key skill is just knowing that you can unfold these 3-dimensional figures in order to understand what the surface area will look like, and then you can calculate it. Make sense?
Yeah.
All right, great job.